Hello, coders. Exciting news today. We have Gregor Riegler. Am I pronouncing your last name correctly?
Yes.
Thank you. So, Gregor is joining us today for a session of kind of a coding interview. And Gregor is a software development coach who is, from what I understand, keen on detecting problems in our industry where we all see a lot of problems, things not going well. And then Gregor wants to help us get to the point of joyful coding, high quality, less frustration, and also, being a bit more ethical in our profession and not putting untested products in front of customers and harming them or frustrating them or making them unhappy. But over to you, Greg. Maybe tell us
Well
a little
put.
bit more about your experiences before we start the coding exercise.
Yes. So, as you said, I'm a software development coach. I'm in the industry for about 15 years now. I started. So I went to a higher technical school. I learned programming there and technical stuff. And I was really frustrated with school. So I had to stop it. I had to quit it. And I moved right into work, programming work. And I did developing smaller web pages and advertisements. At the time, there was, I think it was Adobe Flash, ActionScript, and so on. And when I progressed, I was I found myself in lots of issues with spaghetti code and bad code and so on. And when I started using more frameworks, I realized how well structured they are. So I got interested in all of this, and I started reading into it. And so I got into books and testing and so on and so forth. So I had to switch jobs, and I just learned more and more. And yeah, I'm still learning today.
Yeah,
And I enjoy it very much. And also I enjoy reading your content.
thank you.
Uh, uh, Sometimes I learn things from you that have a lot of value, and that's why I'm here to do. That's why I'm here today.
Excellent. So I think today we're going to learn a lot from you. Um, and thank you again for accepting this interview. So why don't I maybe describe the challenge for you to you, and
Mhm.
then you can just maybe share your screen and walk us through how would you solve this challenge.
Okay.
So here's
Yeah.
this very simple idea. It's very naive and simplistic, but we don't have much time, so we don't want to be spending hours here.
Yeah.
Suppose you want to build a system that will be able to automatically turn on and off light in front of your house. And the decision to turn the light on and off is based on the time of day. Is it nighttime or daytime? And
Hmm.
in addition to that, if it's uh, if it's nighttime and there is no motion, then it turns the lights off to save electricity. But it also can receive the signal from the motion detector that somebody is in front of the house, so it turns it on. So um, I,
Hmm.
I think it's simple enough so that we can have a system that, and we don't have to worry about how it actually turns the light on and off. It just sends a message, and some other system, the IoT can do that. But
I see.
the system you are building is going to determine whether it's time to turn the light on or off, and also additionally maybe motion detector. Make sense?
Yeah. Makes sense.
Thank you.
Um, One question I would like to ask about this is like, what is the bigger picture? What is the what is the motivation for this system?
Um, it's kind of a safety and home alone situation. If
Mhm.
somebody's home alone and doesn't feel safe, and if there's you know, the night time's falling, turn the light off, on in front of the house for a while.
Yeah.
and turn it off because save electricity. But then if there is motion, turn it back on so that the intruder maybe feel discouraged to approach, or that the person in the house can see who is approaching the front door.
Yeah.
That kind of a situation where we want to have some kind of automation. And also when the person is not at home, when everybody's on vacation, it looks like somebody lives there because the lights are being normally used. Turn off during the
I
day.
understand.
Yeah.
So there are quite a lot of features to this system, like, for example, detecting daytime, detecting nighttime. And I'm thinking, like, where can we start? What is the minimum viable thing we could build about this? I don't know, maybe we don't need day and night detection to begin with. What about if we can just turn it on and we can turn it off? And the person using it has to turn it on and has to turn it off.
Okay.
And when the person turns it on, it will start detecting movement. And when it detects a movement, it will turn on the light, something like that.
Yeah, that's over to you.
Would you agree?
Sorry?
Would you agree that this would be like a minimum version of this?
Sure. Yeah, makes sense.
Would it suffice? Okay.
Yeah, I like simple start. Like don't start.
Yes, me too. So I will share my screen. I see a window saying host disabled participant screen sharing. I think you need to allow me to.
Okay, let's see. How do I do that? Share screen. How do I apologize for this. I didn't know that Zoom is complicated like that.
No problem.
Let's see. Okay, I found it. I think you should now be able to try again, please.
Okay, I'm trying again. Yeah, now it works.
Okay.
Sharing my screen.
All right.
Can you see something?
Yeah, I can see your screen. Beautiful.
Okay, cool. So, so we need to write something down. I think the quickest way, if I just wrote it down in this test case.
Okay.
Oh, I don't need that. Hold on. Just write some things there. So what we want is that I have a system and I can turn it on and I can turn it off. And once it is running, it detects movement.
Right.
So when there is a movement, it will turn on light.
Yeah.
Right? So
in addition, sorry to interrupt. In addition to that, the light on has a limited time. Let's say 5 minutes.
Yeah, that's just what I was thinking, right?
Yeah,
right,
okay.
when you say it too. Okay. This is coming up as soon as you talk about it and get more specific, these details come up.
Yeah.
So, so let's say motion detected. When this happens, the light should be turned on. But the light should not be turned on for all times. Yeah. It should be turned on for a specific amount of time. So maybe turn on light for 5. I mean, something like that. Now I'm not yet sure if I put the light turns off after 5 minutes in a different scenario. Maybe let's try. We see if we get there. So light turned after light turned on for 5 minutes. Light turns off.
Yeah.
I will make this a little bit bigger. Only that. And I'm assuming I'm buying a motion detector, and the motion detector already works.
Yeah.
And the motion detector sends me an event, and the event is motion detected.
Yeah.
And then I do something with it. I'm the system that is controlling the light, and I'm turning the light on for this amount of time.
Yeah.
Are there any other cases? So if there is no motion, nothing happens.
Right.
Motion, nothing happens. Let me put this down. All right. And this is the first version, I would say. And later we can have maybe a version 2 where we say the system detects when it is day, something like that.
Yeah.
And I will not go into details. We can discuss this later.
Excellent.
Okay, so of course, let's start with a test. So how do we put that? So I want to check whether actually light turning on can just be another event.
Yeah.
And this can just be a message. Hold on. How do I put it? So I'm saying new. What do I call this system? I don't know. Apertures. I don't know what it's called yet. So let's give it some name. And then there is another thing. There is my motion detector. And now the motion detector sends an event to apertures. Maybe this is just a function like, I don't know, on motion detected. And then there is a light. And the light is on. So we need something representing the light. So I will just say, let's do something like an enum here. It has two values. It's on and it's off. And we need to pass the light to the apertures. So there is the light, and it starts being off. And I want to give the light to my software, to my system. And once it's detected, the light should be on. Yeah, sounds about right. So let's get this test to compile. So I need a light that is an enum. let's just keep it here. Or actually, I wanna keep it here for now. Don't need that. And we have on, we have off, and I have this system. Actually, let's again do it here. And it has this constructor. So let's create it. And on this event, we assert that the light is on. So now we should have a failing test. Let's restart this. Yeah.
Okay.
We expect off to be equal to on, which is not the case. So let's make the test pass, and we say light equals on. Hold on. We can't, because it's an int in a thing, so we need to put it inside of an object, so it has a state. So let's change that. So the light is a class, and the class has a status. So it's a class, and it has a light status. I don't know a better name right now. And there will be a light status with on and off. And this is then the light status. And we need this constructor. And now we can check that let's just add a getter to it. And we can check that light.get status is equal to on. Yeah. And so now, do we now have a failing test again with a better structure? Yeah, we have. So let's make it pass. So we want to say, put this in a field. And then we say light.status equals on. It's not, oh yeah, it was successful. I just didn't see it. Okay, now we got a failing test, a green test. And I don't like this design at all. So let's start and fix it. So there are many things wrong. So first of all, about the name, what is this? We are testing a home security system.
Yeah.
And this is the home security system. And here, let's just call it system for now. That's fine. And the system gets a light, and yeah, the light. Here we are just setting the light like this, but I think rather this should be a method on the light.
Okay.
So let's create a function for it and say this is turn on. And actually, let's move that to the light. I like that much better. Now we have the light, it has a status, and now we can turn it on.
Excellent.
Actually, the status doesn't have to be public, this one.
Mm-hmm.
I mean, yeah, it's fine. It's okay. I mean, it wouldn't have to be exposed here. We could just ask it, is it turned on? Yes or no?
Yeah.
But it's fine for now, I think. Yeah.
So that's your first expectation that's fulfilled, right?
Yes, my first expectation is fulfilled. Yeah. I like it much better now. And now the first case is like turns on light when motion detected. Something like that.
Okay.
Yeah.
What's your next expectation?
What's my next expectation?
Or you want to still elaborate more on your first one? I don't want to rush you.
No. So what about detecting that it turns off the light after 5 minutes?
Yeah, that's logical.
So now we need to bring in the concept of time. How do we do that? So let's copy this test. I don't know the name yet.
Mm-hmm.
Light turns off after 5 min.
Mm-hmm.
So again, we need a light. Maybe let's give it on light now.
Yeah, it's on.
Yeah. And there is no action. Maybe is something like a tick, and some other system is ticking it, and it's counting the ticks. And maybe the tick is coming in after every 1 minute.
Gregor, can I
interrupt? And yeah.
At this point, and this is good line of thinking, and I like it. But to me, and you may disagree, at this point, when you realize that you need this ticker, I would right there consider that a smaller expectation than the expectation within you are working right now. So I mean, this is just me, but I would now branch and have a separate test for this ticker, right?
Yeah.
Separate expectation.
I see. Yeah.
Because I like micro tests. I like those really small classes, like the atomic.
So you now come here, you disable the test because you now know you need this ticker.
Yeah.
To bring in the concept of time, and then you start writing a new test.
You probably
for the ticker.
I'm assuming you're following G. Paul Hill, who is the creator of microtests, and his mantra, his biggest teaching point is take many more smaller steps. So he's big on like, we're not taking a small step, but is there a smaller step at this point? And I think we discovered it, that the smaller step makes more sense. So really, I'm always very keen on like, can I make a smaller step than this one, right?
Yeah.
I hope this makes sense.
Yeah.
Yeah,
Yeah, makes sense. Makes totally sense. We can do that actually.
Yeah, well, let's try that.
So would you say we keep it, we stay within this test, or would you say that we create a new test class for the ticker?
I would create a new micro test. Just we isolate and we just work
yeah.
on this
So
expectation that
let's
something is going to tell us that 5 minutes have passed, right? 5 minutes are.
Yeah, exactly. So we need it. So there needs to be a ticker.
Yeah.
And the ticker,
And another
it
thing,
needs.
if I may just interject, another thing I
Yeah.
like to do, and you may disagree, is sometimes I like to fake it till I make it, and my first pass could be something fake, just to make it.
Yeah, I like that too.
Right?
Yeah.
Then you come back and you really flesh it out.
Yeah. So, but it needs a good design. So the ticker, it needs access to the system clock, and maybe it will tick like every 1 second, for example.
Yeah.
And
you can make it simple. You can just go every minute, right? Because it's not so time.
Or every minute, yeah.
Because
every minute.
5 minutes time.
I wanna test it.
Yeah.
And I don't want to wait 1 minute in test. So I can make a fake time.
Yeah.
And yeah, set whatever.
Yeah, you see, one big thing I think in software is we have the magic power to simulate things, to pretend.
Yeah, exactly.
You don't have to really wait for 1 minute, right? In real time, because then your test is
actually slow. Yeah, actually we can use this clock I think there is a clock interface in Java. So hold on, let's create this class, and I want to create it here. So there is a clock. Yeah. And let's see what interfaces there are. I never remember. Fixed clock. This is fixed. I need to change it. Tick clock. Implementation of a clock that reduces the tick frequency of an underlying clock. Okay, no, that's not what I need. I want something like a fixed clock, but then I want to change it. So maybe it's the ticker is checking the clock all the time, and then it translates the clock that it has into how many minutes went by.
Okay.
That's one idea. But for that, I need a clock that I can change. Or is there something simpler? Is there something like a timeout? Or I say just every. No, if I do it every minute, I cannot test it. It will. I can't wait 1 minute for a test. It's unacceptable. So let's just create some clock.
Yeah, simulated.
You can what did you say?
You can simulate.
Yes.
You can pretend.
I will simulate it. Yeah. So I will I will say this here. This is a field. This is the clock, the time. No, just time. And hold on. And let's move it out of here. This is a fake clock. That's fine, okay. And it should have a function where I can set the time. So let's create a setter for this time. And now we have a fake clock. Now we say clock.setTime. Why is it not? I'm not using the correct type. And I will give it instant dot parse. Let's just start with min. I think it will be easier. And I give the clock to the ticker. And then I will say, how do I assert this? So the ticker needs something it should invoke. It needs another system that it can tick. So the ticker needs a tickable. Oh my God, why is this so complicated? So
we are modeling real world situation.
Yeah. It's a really good example. So it needs something to tick, what it can tick on. So it needs a clock, it needs a tickable. And then I say, when the clock changes to time for like, I don't know, 1 minute, how can I change this? Is this plus seconds 61? After 61 seconds, I expect a ticker assert that ticker.ticked is equal to 1.
Okay.
Let's get this. We need a tickable interface. So let's keep it here. And it needs a tick function. Right now, it only needs a ticked actually. So this is int ticked. And we need a fake tickable. Hold on, no, the ticked actually is a function not on tickable, but on the fake tickable. So here we have void tick, and then we have a public class big tickable implements tickable. Actually, it can't be public, or this will be a problem in lining all the classes. And it needs to implement the tick, but I also want here a ticked. And this is an int. And it starts with 0 exactly. And it takes a clock, but not the fake clock, it just takes a clock. Later it will be the real clock. And now this doesn't work. So let's fix the constructor. And now we got a failing test.
Okay.
So let me read it. Let me read through it. A lot of things happen. So we have a tickable. We have a clock. The clock initializes with the time min, and we say new ticker with clock and min, okay? And we set the time. And after that, we expect that the ticker ticked one time because time ran by 1 minute. So let's make it pass real quick. I can just say ticker ticked. I can just return 1 here and it will pass. Yeah.
Okay, so you're faking it till you make it.
Yes. So let's rename this. What is this? Ticks one time after a minute. And yeah, I don't like that this takes 2 lines, honestly. So let's say create block. And yeah. Maybe let's move this down here for now. Passes, okay. Yeah, it's much better now. Okay, so but obviously my implementation is garbage. So let's change that. Let's make another test. So actually, it doesn't tick after 50 seconds.